I'm going to show you about shortcut multiplying, which actually is in level D. This presentation won't make much sense to you unless you're familiar with grouping in fives, and I hope everybody is. You can multiply up to 10 times 10 on the AL Abacus. That should be a given. And you're curious about why things work. So let's do 7 times 8. I'm using the bottom 2 wires of the abacus. Put 7 on the second wire from the bottom and 8 on the last wire. And this method was used in the Middle Ages, so it's not that new. Now to find the tens, notice the number of dark colored beads, the blue ones. And we can see there's 2 and 3 or 5. So 20 and 30 make 50. That's our tens. To find our ones, we look on the right side and multiply the 3 times the 2, and we get 6. So 7 times 8 is 50 plus 6, or 56. That's cool, right? Let's do another one, 9 times 7. I'm putting 9 on the second wire from the bottom, 7 on the bottom wire. The number of tens is 40 and 20, which is 60. And the number of ones is 1 times 3 is 3. So the total, 9 times 7 is 63. Now the beauty of this is you can actually do this in your head. You can see these numbers in your head. Now here's why it works. Okay, there's a 7n times 8. Remember we had 50, we had 5 tens. So there's 5 tens, but there's a little problem up there. On the right, we have that rectangle, 3 times 5. Where is that? Actually, it's right there. Amazing. And then to get the ones, remember, it's 3 times 2. There it is, 2 times 3. So there is our answer. 7 times 8 is 56. You could actually, if you wanted to, take these up here and actually move them over here. But I think it's easier to see it this way. Let's try our other example, 9 times 7. The number of tens is 60. But again, we've got the 1 times 6 is missing, but it's, lo and behold, right over there. And then our ones is 1 times 3, and there it is on the bottom wire. And I always said I could prove this algebraically. It's quite easy if you know elementary algebra. But now you can see it physically why it works. Here's another example. This is has a little something different in it. 6 times 6. The number of tens is 20. But then we've got that 2 times 4. We'll move that over there. 4 times 2. And then we have 4 times 4 is 16. There it is. So 6 times 6 is 20 plus 16, 36. And this also works even if one of the factors is not 5, even if it's less than 5. But when you do this, you have to take in consideration how many you're missing, how many yellow ones are missing. And they must be subtracted. So let's do 9 times 4. There's 4 blue beads on the second row from the bottom, which gives us 40. Then we have to subtract 10 for the missing yellow one. So that's 30 is our tens. Then to get our ones, as usual, we multiply 1 times 6 is 6. And the answer then is 36, which indeed it is. Now, wherever you can multiply, you can always divide. And 2 days after I figured out why this works on the abacus, actually it was 1:30 in the morning one evening when I couldn't sleep. 2 days later, I figured out how you can do division on this. Now I'm writing the problem both ways, as a division problem and missing factor problem. So let's do 72 divided by 8. Now we know we have one factor, which is 8, so I'll put that on the second wire from the bottom. But we don't know the bottom one. But we know the number of tens has to be 30 plus what will make 70. It has to be 4. So let's put on our 9. And now let's check the ones. 2 times 1 is 2. It works. 72 divided by 8 is 9. And I think it's helpful to see it the second way. 8 times 9 is 72. Isn't that cool? Let's do another example. 48 divided by 6. We know the first factor will be 6. And how many 10s do we need for the second one? Well, 10 plus what makes 40? It looks like it's going to be 30. Now let's check the ones. 4 times 2 is 8. No problem. Okay, let's try 42 divided by 7. We enter 7 for the first factor, and to find the second one, 20 plus what makes 40? It's going to be 20. Now let's check the ones. 3 times 3 is 9. Uh-oh. 40 plus 9 does not equal 42. So as often happens in division, we have to go down 1. So instead of trying a 7, let's try a 6. 20 plus 10 is 30. And the ones, 3 times 4 is 12. 30 and 12 is 42. It works. And as somebody pointed out last week, the reason this happens is that there are 2 products for 7 in the 40s, 42 and 49. The 8s don't have that and the 9s don't have that. So it's the 7 that has this problem. But that's okay. It's very easily solved. And the interesting thing is you can even do this. Like we could even do 43 divided by 7. You could do it with remainders. I'm not going to show you how to do that. I think it's just, you have to play around with this first to understand that.